Okay. So you guys are aware that what is the course which we are going to start today?
Yes, sir.
How many students are there in finance group this time?
40, I believe.
Okay.
Um,
And this CR and all everything has been decided, or we had to
no, sir.
bother Paras only?
For now, sir, first they'll have to wait for council selections and then CR will be elected.
So another 10, 15 days or before?
So council's second rounds are done. So I guess another 10 days before maybe we get a CR.
Done. Acha, have you gone through the all of you have got both the softwares uploaded on your desktop, laptop?
Yes, sir.
All of you? Because we'll give you
Yes,
some
sir.
assignment immediately, so that in a way I'll check that you have got the access to software or not. So without software, there's no learning on these courses.
So we just have to try the starter software to ensure that it's the same thing that you wanted. Otherwise, the e-views is proper. I tried both of them, but it seemed proper.
So this is I'm just starting. I have the official version, obviously.
Yeah.
There's 15. You guys might be having 16 if I remember correctly. Is
Yeah,
this
yeah.
the first window which comes out when you
Yes.
open it?
Yes, sir.
Institution has licensed version. I'm using that one. ठीक है. And we have e-views, as you were saying that my e-views is 11 again licensed. I don't know yours. You have got the student version. Student version. So it will have some limitation in terms of saving, keeping the record of work which you have done, and some limitation in terms of having the size as well. Otherwise, student version is perfect to serve our purpose. And moreover, we have starter, so anything can be done on a starter. There are few things which are typically done on e-views, which are easier in doing as compared to on starter. So it is better to have a balance. Bhavna, I mean, this I can't help. You should have spoken to me yesterday.
Yes,
Through
sir. Sure. Sorry,
Paras,
sir. I'll
or
figure it out and I'll
uh,
download it by
every
today.
year it happens. So people have to look for some solution.
Yes, sir.
So
I'll do that.
you
And
check
I
with your
support your
seniors
details.
or Paras. And still you have a problem, get back to me. I'll connect you to Rajesh. He will help you.
Right. Thank you so much, sir.
And there's no need to put things on chat box. Just unmute and talk. So we are starting, and this course I have divided into 12 parts. 12 parts means if I broadly discuss with you what are the 12 parts. So, first of all, let me have a brief discussion on why exactly we are doing this course, and then I'll come to the syllabus part also. Let's answer this question. What is your understanding? Why do we have this course, that too in first semester, that too in financial specialization area? Question for you, you need to answer. Go ahead. Yes. Why we have this course? Or what is your understanding about this course?
I guess in the next few semesters, we have many subjects related to financial markets. So this subject will help us in analyzing the data which we'll be using in those subjects, or in general, the data which we'll be using in capital markets.
If I take the points raised by Anubhav, do you think that the looking at the financial data, the job of this job of trying to analyze things and all, everything will get over by the time you have completed your MBA, or that will start?
No, sir, we will be starting
So
it.
Anubhav, hold, let other people react. Yes. Come on, talk, bhai.
So I've done financial econometrics. So the essence of it is basically essential for risk management. It is very essential for risk management, applied econometrics, financial.
That's
Basically,
it. I mean, by the time we have no career in financial risk management, so there's no utility of understanding how to analyze financial data.
pardon, sir, I didn't understand that question.
I'm saying by the time financial risk management is over, there is no other area in business or in finance where analysis of data is important.
Uh, so you can always use it on stock data to analyze the volatility of the stocks and whether it's a bad investment or a good investment, basically to some extent. You can use stocks and
Any other view?
So it's
No, this is needed because here we are incorporating all the principles of economics as well as statistics and building a financial model and trying to implement theories into practice.
Okay. Okay. Okay, one thing I quite often ask, what do we do in business? What is the main thing which we do? Somewhere or the other, do you believe that we take decision making? We do decision making at all the levels of corporate world, everywhere, whether it's top or at the elementary level. Everyone is supposed to take decision. Does this argument make sense? Yes or no?
yes, sir.
Yes,
You
sir.
have decided to do MBA from SIBM Pune. You might have got other offers also, but you take a call, conscious call that you would like to join SIBM Pune. So people take decision. Business is also nothing but decision making at different point of time. If you look at how people take decision, including your decision maybe of deciding of joining SIBM, there are two extremes. One extreme we take, some gut feel, hunch, and on the other extreme, you will find that we take very informed decision making. Do you believe if I say this way that either we are using completely hunch or extremes? If I talk, then you have got some model and then you are getting some input. Reality is somewhere in between. Maybe some people use hunch more, and some people use model more. But reality lies somewhere here. I mean, and if I just try to understand that how people take decision making, especially in business, then that's a reality. Do you buy the idea?
Yes, sir. Yes, sir.
Let's say you have decided that you would like to take admission. So you might have 5, 6 priorities. You write down those priorities, and you start. You have got 4, 5 institutions where you have got, let's say, 3 institutions where you have got offer. Then you start ticking that whether this feature is there in this institute or not. And likewise, you probably at the end you would have calculated that yes, I'm getting maximum features, maximum characteristics or requirement of mine are being fulfilled in a particular institute, and then you take a call. Yes, this is the institute where I should take the admission. Again, after doing this exercise, it is quite possible that your intuition, your mind says this is the right judgment, but your heart says something else. And again, you might revise your decision, may not opt for the first, but second best might be your choice. That is also a possibility. So that's why I'm saying that the real decision making is not neither at this extreme nor at the this extreme, rather somewhere in between. That depends on person to person. Let's talk about this. What is informed decision making? Just please react to it. I have given one, 3, 4. Have you gone through the material which I have shared? RS would have communicated to you.
yes, sir, I forwarded it on the group.
No, I'm asking everyone. Have you gone through the material which are there on the Teams?
I saw the simple and multiple regression one. In the first one, sir,
We'll come to it. We'll come to it. I'm talking about the first chapter, introduction, and there I gave some material of informed decision making, 3, 4 PDFs. Has anyone got time to go through that? Just skim through. Have you skimmed?
um,
So if I just take some context with that informed decision making. Okay, use your common sense. Tell me, common sense, using your common sense, what is the idea about informed decision making? How do you view it? Especially in the present
Uh,
scenario when we
the
have got overflow of information, a lot of data, there's no end to it. If you want data or information, and within that, you have to take decisions. So how do you see, how do you visualize when I say informed decision making?
So decision that is backed by structured data.
So up to what extent do you think that business should rely upon an informed decision making? Is it important, relevant? Up to what extent it is relevant, or it is relevant only at the elementary level, middle level, or top level, or at every level you find that informed decision making makes sense? What's your opinion? We are still talking about decision making.
so the informed decision making is required at each and every level, because if we are talking in business terms, it cannot run on gut feel. Every decision should be backed by data, some data or facts that you can say corroborate your decision.
I give you one very good example. I mean, nowadays you might find that banks have got a lot of cash available with them, but they are not giving loans to people. Do you know why they are not giving? Anyone can react to it quickly. Why banks are not extending loans to corporate,
Due to
despite they have a lot
macroeconomic,
of cash with them?
yeah, due to macroeconomic parameters.
No, 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 no. Something more relevant. Anyone
The
quickly?
GDP is, I mean,
No,
shrinking, so
no,
not
no, no.
that
Real,
much
no,
The
no,
activity.
no.
earnings
Re-
of corporates are not growing.
No, 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 no. If you
Uncertain
try to
times.
understand uncertainty,
It's
rather I
not.
would say that when suppose one bank manager gives loan, and as long as there is no problem, nothing will happen. But suppose that loan becomes bad, then the very first question which will come is who has sanctioned that loan. So that bank manager will be in soup, will be in problem. So what happened that bank manager, especially in this public sector bank, what they think that's better not to give loan. If there is any doubt, they straight away say no. Why I'm referring to this scenario? Because if you have informed decision making, means certain standards. Private sector banks, they work on a different platform. They have some, you could say, some standardization or some categories, or they have some checkpoints. Let's say they have, 7, 8 checkpoints, and they will say that one application one is there. Then they will check and whether all the requirements are fulfilled or not. And once it is fulfilled, they do not find any problem and they sanction the loan. But probably this type of situations are not available with the public sector bank. They are not that structured at the bank branch level as compared to the private sector bank. Why I'm referring, because when I'm saying that this type of checklist or more standardized software or ERP systems are there in banks. Basically, I'm referring to informed decision making. They have already done a lot of work, and then they have converted that work into some sort of model so that they can take a call whether to give loan or not to give loan. One of the important tools, discriminant analysis, again, some application of multivariate data analysis. I'm referring to data sciences. This is a very important tool, discriminant analysis, which is used for the decision of whether to give data or whether to give loan or not to give loan. Why I'm referring to these things, I'm just trying to highlight the role of processed data in business. So it is the informed decision making which matters a lot when we talk about anything which is sensitive. This is one of the sensitive things, whether to give loan or not to give loan. If I give you a few more examples, there is a mutual fund, and in a mutual fund, you have got asset management company. They are supposed to manage the asset. And what happened? It's not their money, obviously. Unit holders are there. Mutual fund, a particular scheme, unit holders, they give money to mutual fund firm. AMC is supposed to manage. And when they have to put the money, as long as there's no problem, nobody will ask. But suppose there are some problem, market might have fallen down, the wealth would have gone down significantly, NAV is falling, then people will ask that on what basis you would have made the investment. So question may be internal for mutual fund, maybe external. And if you understand, we are catching up with a new phenomena which we call shareholder activism. I mean, not only the customers, but we have HDFC AMC, which is a public limited firm. Do you understand that when I say HDFC AMC is a public limited firm?
Yeah, it's
Yes, sir.
HDFC Asset Management Company, it's a professional company, it's a public limited company also. So they have shareholders. They can also ask questions on what basis you would have decided to invest money of unit holders in a particular asset class or in a particular firm. Point here is the people, not only here as I was talking about bankers, but mutual fund, AMC people, portfolio managers. I guess you are understanding these terms, bankers, portfolio managers. I can take the liberty of using them.
Yes, sir.
Yes, sir.
Portfolio manager, you understand?
Yes, sir.
Yes, sir.
yes, sir. Yes, sir.
Portfolio managers, they are better off if they have taken their decision on some basis, and that basis is nothing but the informed decision making. They have decided to invest money in a particular firm on the basis of certain criteria, and that criteria is again some sort of application of some statistical, econometric, or maybe artificial intelligence or machine learning tools. So the decisions are based upon certain method. That method is valid method, and that method is nothing but the application of informed decision making. My purpose of giving both the example to you, whether it is of portfolio manager or of the banker, that I am trying to bring your attention that decision making nowadays, especially when we have more and more information. Earlier it was not. 5 years, 10 years before, the scene was not like that. But as we are getting more and more data, this role of informed decision making is becoming very important. So it means we have to have some tools so that we become informed. So very important. I give you one more quick example. Have you recently followed a news item where SEBI has said that he is talking about different class of investors, and one class of investor he is calling them accredited investor. Have you gone through the news item? Accredited investors. They are the investors who are supposed to be informed investors. So what I mean, SEBI, regulatory body in India, which regulate the capital market or the stock market in India, they are also dividing investors between two categories. One uninformed, another is informed. So when we say uninformed, informed, what is differentiating between the two is whether people have access to understanding the situation in reality, in totality or not. So all these examples which I'm giving to you, I'm just trying to bring the point home that this informed decision making is becoming more important than what it was even 5 years before from today. So what happened? We have, if I look at how to get information, we do simple data analysis. Simple data analysis or simple financial analysis, they have their own role to play. I'm not saying they do not have their role to play. But again, you are needing more things like Paras was talking about volatility. If I ask you a simple thing, volatility, how to calculate that? Anyone can talk about it? How to calculate volatility? People talk about volatility very casually about the stock market. That market is very volatile. What do you mean by volatility?
The fluctuations, the degree of
Fluctuation.
fluctuations.
I agree with Jan, he is correct, but how to measure fluctuation?
So
More
the
important.
difference between the
Standard
price that the
deviation is very primitive way of estimating the volatility in the market. Very primitive. I'm not saying it's not good, but primitive. What about advanced ways of calculating the volatility?
so the difference between the price that the buyer is willing to pay and the seller is willing to receive.
No, that's not volatility. Fluctuation in price, variability in price or return can be termed as variability or volatility. That's we can call it a spread. That's different thing altogether. Difference between prices, it's not volatility. Change in price or change in return may be termed as volatility. So
Deviation in beta.
beta is a different thing altogether. Again, we are talking about measurement of systematic risk. So it reflects risk, but the purpose of beta is different, and purpose of volatility, plain simple volatility, are different things. So means what I am saying, that informed decision making is very important. Now the question is how people become informed. How can people take informed decision making? So we need certain areas, certain courses, certain knowledge which help people take more informed decision making. And I'll divide this informed decision making thing into statistical learning. I'm calling it SL, so that you make sense when you can understand and compare with machine learning. And I'm putting artificial intelligence together. When people get to know about the information in more processed way, I'm calling that processed information as informed. When people are informed, and then they can take that decision. So somewhere or the other, statistical learning and machine learning both help a lot in making people more aware, more informed, so that they can take more informed decision making, more appropriate decision, so that they are benefited. If I put this discussion to a different platform, let's say I'm saying that I'm machine learning, artificial intelligence here, and I'm saying let's put statistical learning. First of all, you understand statistical learning. I mean, the conventional, including this course, which we are going to talk about, financial econometrics, is also coming in the domain of statistical learning. Statistics, econometrics, all these things put together can be called as statistical learning. So what happened, suppose I'm calling this data scientist, data sciences, which is the extreme of application of giving the information to people to take decisions. So decision sciences, even COVID, for example, a lot of information is generated. How people are generating information, even prediction, all these, even decision about vaccines, all these things are somewhere or the other linked with data scientists. People are working on data and they are drawing conclusions, so that people can take more informed decisions. Now the question is, when we talk about extreme of data sciences, one more area which comes into picture is IT, information technology. And you want to be very good at data science, you want to be very good at this. Data science is application of machine learning, artificial intelligence. There are two ways by which you can start as a IT professional, you get hold over it, but you will find that unless until you understand a statistical understanding you have, unless until you have statistical learning, you won't be very good data scientist. Not possible. So it means it's not that without IT you can survive, but you can't survive without statistical learning. Other way, this is the one way to become good at data science. Sciences, you are IT professional, and you start, that is your strongest area. You gradually acquire better skills of data sciences, but you have to have the understanding about statistical learning. Second approach could be, you are a statistical learner person, I mean learning person, you are good at statistics or having the knowledge on statistical learning, and then you acquire knowledge about machine learning, but that will also again remain incomplete unless until you get to know the things about IT. I hope you are understanding the point. What I'm saying, if you want to become very good at data, handling data so that you can have a lot of information about different things, there are two ways by which you can do. You want to become good data scientist, either you start from IT area or you start from the statistical area. But at the end of the day, when you start from IT area, you have to end up learning statistical learning. And if you start with statistical learning, you may get good hold over machine learning or data sciences, but again, you have to have good understanding about the IT also. Why I'm talking about this? Because we are right now not intended to become data scientists. We are finance professionals. But obviously, we would like to make use of information, processed information. So what happened? We might be somewhere here. When I say we might be somewhere here, it means it is not that only machine learning knowledge will make you good at data handling. Rather, you have to have reasonably good. I mean, either you are good at this or good at this, and even if you are good at this, at the end of the day, you have to have this knowledge also. Then only you will be in a position to make best use of data handling. Hope I am making some point to you. If you want to become very good at handling data, having the informed decision making, you have to have not only the knowledge about machine learning, but you have to have the understanding about the statistical learning, and you have to have the idea about IT. But just because we are finance professionals, so as I'm saying, we will be obviously, learning this. Learning statistical learning cannot be avoided in any form if you want to make use of data science in any way. Are you getting the idea which I'm trying to communicate to you?
Yes, sir.
What is machine learning according to you?
So machine learning is where we give the computer a set of previously recorded data, and the computer understands or analyzes future data and gives us a result like that.
So you enter some information, and machine learning tools, whether you are using R or Python or any other thing, it is processed and you get the output. Practically, you are not aware what is happening inside. This is the application of machine learning. But what about understanding the concepts? Why something is happening and why something is not happening? That can be understood only by machine learning.
So I didn't get your question.
I'm saying machine learning is a black box where you enter some information and you get some information. I mean, you enter some data, you get some information. But why and what way things are getting processed? What are the causes and what are the effects, and why some particular effect is coming up? Can we understand that thing in machine learning?
No, sir.
Anyone else who has got any idea about machine learning?
So use of algorithm which adjusts itself according to the data and take decisions accordingly.
What you're saying is more appropriate for artificial intelligence. So, whether we are talking about machine learning or artificial intelligence, the cause and effect is not very clear. Anyone else who has got idea about machine learning? I'm intentionally talking about machine learning so that when I start statistical learning, you are not feeling that machine learning and statistical learning are entirely two different things. They are not competing with each other. They are complementing each other. I'll come to statistical learning. That is something which we have to talk. But I want to have a clarity. Yeah, somebody else who have got more exposure on machine learning.
So basically, it is a method of data analysis which builds analytical models. Basically, it works on algorithms. And So basically, there are two types of machine learning. One is supervised and the other is unsupervised. And basically, the task is you give it some patterns, and in unsupervised method, it performs on its own. It finds patterns on its own in there.
Huh. By the time you say it finds pattern, we move from machine learning to artificial intelligence. As we have just heard three people talking about machine learning, one thing you would have realized that machine learning, including artificial intelligence, does not talk much about what are the causes or how the impact, if it is happening in a particular way. Let's say, for example, suppose I say that the price of a particular mutual fund scheme is going up. You would like to find out the determinants which are causing the particular type of mutual fund scheme prices to go up. So probably machine learning or artificial intelligence will be able to give you some random judgment. Random in the sense you enter the data that will be able to tell whether these information which you have entered will be able to help in finding out the its impact on the price of NAV or not. So impact may be found, but why this impact is happening on the NAV of a particular scheme price by the variables, that logic cannot be explained with the help of machine learning or artificial intelligence. So the things may be lost in building the model, using the algorithm to build the problem and trying to find out the solution. But solution is processed in a black box way. So you do not know why, if something is happening, why it is happening. That is not clear when we talk about machine learning. That's why if you speak to data scientists, you will understand that they look forward to statistical learning to complement their understanding or complement their whole process of doing the analysis using machine learning. Point here is, if I recapitulate whatever I said regarding this, this statistical learning and machine learning, they complement each other. It is wrong to say that just because machine learning, artificial intelligence has come, so the role of statistical learning is over. It is absolutely not correct. Rather, it is more correct to say that if you want to really become good at machine learning or artificial intelligence, not only as I try to draw here, you need not be, I mean, you need to be reasonably good at IT, but ultimately, if you are starting from here, you have to have good understanding of statistical learning also. When I say statistical learning, so now I'm coming to my course. When we say statistical learning, so this term I'll be using.
Sir, there is a disturbance in your mic. I mean, it is difficult for us to hear, I think.
Is it better now?
Yes, sir.
So I have discussed two things about decision making. I said two extremes: informed decision making and hunch. Second thing, I try to give you some brief about statistical learning versus machine learning, and I insist that statistical learning complements the knowledge of machine learning. It's not competing with each other, rather they are complementing with each other. Keeping that thing in mind, um, if I try to define statistical learning, have you heard the term before? What is statistics? According to you, what is statistics? Yes. What is statistics?
Representation of data. I mean,
Is that statistics?
I mean, just a layman term.
Use your common sense only. What else? One part is okay. What Jen said makes sense.
Computing raw data to make sense and information out of it.
Okay. Okay. Anything else?
Structured data, working on structured data.
Statistics is used in two ways. One is obviously presentation of data. I mean, like presentation of data. In one way or the other, you make table, put things together, and then show. That is also, that's why we say, what is the statistics? So we are talking about presentation of data in one way or the other. Other is we call tools to take or tools to take decision making may not be very great if I say that way, or tools to process the data. That may be more appropriate. Tools to process the data. When I say statistics in this way, so simple example, suppose I'm studying, let's say 1,000 people in a particular area, and I have to study what are their, something very simple, let's say weight. I would like to know whether they're obese or not. And studying 1,000 people may be very difficult. I may draw a sample, let's say, of 50 people. I study them and I figure out some weight. And what I'm saying that this weight, if I put it weight one, and this I have studied with the help of 50 people, not 1,000 people. And then what I'm doing, I'm trying to generalize the information generated with the help of 50 people. And I'm saying that the result which I've generated on 50 people makes sense for 1,000 people. So this generalization is not that easy. You have to use the science. That science is the second part when I say process the data. So statistics can be plain simple presentation of data, and this is also we call statistics. So when we process the data, and one example, one of the examples I have given you, that using sample to draw inferences about the population, and we call it inferential statistics. Inferential statistics. If I put it, we call it descriptive statistics. If you understand a little bit about statistics. So statistics is not only description of the variables or information, but it is inferential also, where we draw conclusion, inferences, not from the whole data, not from the census, but from the sample. And this exercise, so they are the two broad divisions of statistics. What happened when we apply? This is always part and parcel of the game, descriptive statistics. But this inferential, are you getting the inferential statistics? Yes.
Yes, inferencing from a sample data.
We can say that we have a larger chunk of people or things. We want to study about them. Studying about the whole lot may be very time consuming. It may take a lot of efforts, and it may be costly also in terms of money. So three things are there. It may be costly, it may take a lot of efforts, it may take a lot of time. Just to avoid these three things, we may draw a sample. Sample has to be drawn very technically. It can't be, very casually done. And then drawing some information from sample and using it for the population. Again, some tricks are involved, and tricks are really very serious tricks. So that is what inferential statistics is. And then I can correlate this inferential statistics. Descriptive is always part and parcel of that. When we try to solve the economics problem, economics, I put it business, or let's go for a micro set of inferential statistics in finance. So probably application of inferential statistics for, I repeat, application of inferential statistics for the problems of real problems of economics, business, or finance can be termed as econometrics. Econometrics. And suppose when we are exclusively talking about solving the problem of finance or handling the issues of finance, we are talking about financial econometrics, and that's what our course is. Financial econometrics. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Then I think I have a slide on definition of econometrics. Yes. So I've just took it. So we apply a lot of statistical learning to solve the economic, business, or financial problem. That's nothing but econometrics. Or when we are talking about exclusively solving the financial problem, we are talking about financial econometrics. So I still stick to my idea, which I started with. Decision making is the key in business. Informed decision making is something which we can't avoid. Informed decision making is nothing but having the information. Information comes from analyzing the data. So whether you are analyzing the data with the help of machine learning, artificial intelligence, or statistical learning, ultimately people are becoming aware. They are more informed. They have more information to take decision making. And as I said, that machine learning may be the next step if you want to improve your understanding of data. But machine learning is also incomplete unless until whether you are coming from IT side or you are coming from the statistics side, machine learning is incomplete without the knowledge of statistical learning. It's not that I'm hard selling statistics or econometrics, absolutely not. You talk to somebody who's well aware of these things, he will say what I'm saying. So statistical learning cannot be avoided. Coming to a little bit more about the introductory part, and I'll move to second chapter. When we look at data, can you quickly tell me types of data? So far, we have understood that we need to process the data so that we become more informed. So this is as simple as this. We want to be more informed so that we can take more appropriate decision. So we are going to use statistical learning to become more informed. So informed means we will be generating more information. Question is, from data we are going to generate more information. Now the basic questions, we are coming to more basic things. Types of data. Come on.
Structured and unstructured data.
So that's a different context. Be a little more simple.
Qualitative
and quantitative.
Qualitative, quantitative may make sense. One of the classifications. There are several classifications: quantitative and qualitative. Okay, I'll call it categorical and numerical. I prefer to call this term categorical and numerical. Some people call it metric, non-metric, categorical, qualitative, and non-metric. So these are one classification: non-metric versus metric. I repeat myself: quantitative versus qualitative, numerical versus categorical, and metric versus non-metric. So all these three set of terms can be used interchangeably. So this is one of the classifications of data, but that's not the end of it. Tell me more. If you're aware, I'll tell you otherwise.
discrete and continuous.
And continuous makes sense. Discrete and continuous. I guess you understand when you have, you count people 1, 2, 3. You can't have 1.3%. But when you are talking about height or weight, you can say 1.3 meters. So that is possible. So when any number can be taken, it is continuous. When only certain set of numbers can be taken, we are talking about discrete type of data. More classification. Yes, I'm waiting.
Yes, sir.
No, I'm saying more classification of data.
Structured, unstructured.
Oh, that's okay. Something else.
So maybe finite and infinite.
No, that's again we are not referring to. That's a particular case of a different situation. So two things I'll add here: measurement of a scale. Somebody discuss with you measurement of a scale in your start course so far? Yes or no? Measurement of a scale?
No, sir.
There are four measurement of scale. Again, we say that broadly, one is categorical, other is numerical. In categorical, we have got nominal data. Have you heard the term before?
Yes, sir.
Nominal data and ordinal. Most of you would have heard the term before.
Yes, sir.
And then we have got interval scale and ratio scale. May I assume that you guys understand this?
Sir, don't assume that. Sorry.
I'll get back to it again. Measurement of scale, but I'll request that use a little bit other sources, maybe Google, type it, measurement of scale, type interval scale, something, try to understand that. It's too basic. And you are not clear, get back to me. You guys have my mail ID and number. You message me. If you're not clear, I'll talk.
Sure. Thank you.
I have time for you, don't you worry. As long as I'm teaching a course, I have time. Within
Thank
same
you.
day, I'll get back to you. But you make some efforts. Not
Sure.
clear, get back to me, and no hesitation in getting back to me.
Sure, sir. Thank you.
Four. So I talked about, please don't take this thing very lightly. Data is very important. We are starting with with becoming more informed. So we have to understand what are the data which we are going to handle. So data, as I am saying that one classification, we are saying non-metric, metric, something. Um, uh, Suppose you are talking about roll numbers, or you're talking about names. So, or your CGPA in grades. So when we talk about grades, it is not any, it can't take any number. So whether it is roll number, names, your grades, we are talking about categories. Grades are nothing but let us 7, 8 categories. So that type of data is qualitative, categorical, or non-metric data. On the other hand, let's say we're talking about your marks in a particular course. So maximum marks may be 100, I mean percentage wise, let's say we are saying 100% may be there, but it can take practically any number. So it means percentage or plain simple marks, let's say out of 100 you are getting, out of 70 you are getting some marks. So your weight, your height, so these type of variables are metric, or these type of data can be termed as metric, quantitative, or numerical data. So a brief classification of categorical versus numerical data. Second, discrete and continuous, both can be clubbed, but they can be understood in isolation as well. Measurement of a scale, I said that broadly, measurement of scale can be divided into two broad categories. We say that categorical data and numerical. I'm taking this nomenclature from here. And categorical measurement of a scale can be further divided into two parts: nominal data and ordinal data. Nominal is like your names, your roll numbers, where nothing is important. No, maybe number, roll numbers have number, but that is used to identify. So something when it is used to identify, we talk about nominal. Ordinal, your CGPA will be ordinal, means A is better than B is better than C. So wherever grade rating, they are our ordinal data. So where order is there, but in absolute way, if somebody has got B, somebody has got A, but you can't say how much is the quantitative difference. It is the grade difference. So order-wise things are clear, but in numbers, in terms of clear-cut numbers, you can't say who is better. I mean, how far, by how much numbers people are better in A than B, that cannot be generalized in the ordinal data. Interval scale, the best example to understand interval scale is when you have 0 as one of the values of the variable, like temperature. There could be a 0 temperature, minus degree, plus degree. Profit and loss, profit can be and loss can be 0. If it is negative, it is a loss. If it is positive, it is profit. So that type of variable, if I say profit and loss or temperature, where 0 can be one of the values, then we are talking about interval scale. Ratio scale, practically when 0 is the absence of that thing, like, when we have height, zero height means nothing, end of it. That height is not there. So that type of measurement scale which are applied on a particular data is ratio scale. Brief, I have given very brief. So I believe that you will be able to learn on your own. And still, if you're not clear, get back to me offline. Fourth, which is the most important thing, which intentionally, this is something which I wanted to talk about. I would like to divide data into cross-section, time series, and panel data. How many of you understand this? Because when we talk about finance, we are dealing with this type of data or this type of classification. And this type of classification makes more sense when we talk about application of statistics or econometrics to solve the real life business or finance problems. So this classification is also, or rather, more important as compared to others. Other classifications are also equally important, but they are making more sense because different models, different approaches are based upon what type of data we are handling. According to the data, we decide that this method may work or this method may not work. So cross-sectional data, you guys understand cross-sectional data?
No, sir.
Any one of you?
So when data is collected at a single point of time for one variable, or
Abhishek
one
is
or more.
absolutely correct. You are studying different variables. let's say I'm talking about GDP, or let's say profit after tax, PAT. I'm talking about PAT, let's say the financial year 1920. And on this particular financial year, I have got the data of, let's say, BSE 30 companies. So at a one particular point of time, I'm getting one variable PAT for 30 firms. So this is an example of cross-sectional data. Cross-sectional means, as Abhishek said correctly, at a particular point of time, when time is one, and you may have, let's say, it's not only PAT, but you have got sales, and you have got operating profit. I guess you have attended my class day before yesterday. So you have got sales, you have got operating profit, you have got PAT. So now we have how many variables? One, I can put it this way, name of the company, C1, C2, likewise we have got 30 companies, and we have got a variable, let's say PAT, operating profit, and we have got sales. I can have more variables. So this is variable 1, this is variable 2, this is variable 3, and these are 30 and 30 companies, and I've got all the data points ready. So this is one of the example. All data is collected for 2019, 2020. So this is cross-sectional data. Are you together? Yes?
Yes, sir.
But data is at a particular point of time. We call it cross-sectional data.
So, sir, the data should be at a single instant or it can be a period?
Time period has to be one, na?
Mohit, sir.
Mohit, what happened? The financial data usually either it is collected quarterly, monthly, or annually. If you talk about audited financial results, it has to be annually. Are you with me? Audited means the auditing body audits, confirms that information given by the company is correct. That's a tedious process, costly process. So every now and then, let's say every quarter, it cannot be done. So our SEBI also allows companies to publish audited result only once in a year. So that's why usually when we say across the world, it's not India only, you'll find that these data audited are annually presented. So point of time is 1 year. I hope you understood, Mohit.
Yes.
Point well taken, and keep on asking such questions. Don't you worry. Don't rate your question low. If you have doubt, unmute and talk.
Sir, can you please repeat once again the type of data you said? This is, I forgot the name actually.
Cross-sectional data.
Cross, okay, got it, sir.
Cross-sectional. You will become used to these terminologies, don't you worry. They are a little data oriented, don't you worry. You can't avoid data from your life. Your salary is in numbers or something else. You want salaries in numbers or your age is number or something else. So data you can't avoid. It's part and parcel, and you have to, HR people, I don't know whether they understand analytics has become part and parcel of HR. Who will fit the bill? It's the most trickiest question, which can't be answered with the help of talking only. You have to have models now. At least you need to be informed. It means you have to be good at processing the data. Gone those days when marketing professionals were only convincing people and getting the job done. No, now a lot of IT involvement, a lot of processing of data is there. You can't live without ability or skills. If you are not doing, at least you should be in position to understand it. So either ways, you have to be good at handling data. Finance, one of the difficult areas. You want to go into portfolio management business. You want to become equity researcher. You want to analyze the equity analyst. You have to have understanding about many things. You want to talk about, as this Paras was talking about, risk management. Even if you want to go for derivatives, okay, you need to have many things about market. I'm not saying that those things are not important, but many critical decisions are taken on the basis of things which are completely data driven. You have to have holdover skills to process the data. And if you are not doing how to process, at least you would be in position to understand, process the data so that you can use the information for decision making. So either ways, whether you process it or you understand the process data, you need to have these understanding. So gone those days when we were living without numbers. You have to start liking numbers. I insist on that. Coming back to my discussion, cross-sectional time series we are talking about. And very soon you will find that these data terms become normal terms. Like profit and loss we talk about, we'll talk about all these data terms also very soon. Just wait 5 years down the line, you realize what I'm saying. Next is first classification, I said cross-sectional. Second, I'm talking about time series. Putting time series, very simple. Time series can be understood as two variable. Actually, let me give you a very quickly idea. What do you mean by variable when I'm saying? When I'm saying variable, what I'm referring to? I'm giving you one very basic thing. What is variable?
That's something that is dependent on another thing.
No, that's not very good at to talk about variable. It can be independent also. It can be dependent also. It can be control variable also. So that definition is not correct.
Sir, anything that is fixed, it can change at any time.
Anything
Which is not fixed, it can change it at any time.
ठीक है, that's okay. But something else? Yeah, feel free. Come on, unmute and talk.
Yeah, whose value influences the final output?
Okay, ठीक है. I'm defining it in a slightly different way. What I'm saying, whatever I want to study, that is fixed, not fixed, variable, control, independent, I don't know. If I want to study something, that thing is variable for me. Can I define that way? What I want to study, that is variable for me. Yes? Are you with me? I want to study weight,
Yes.
that's variable. I want to study height, that is. I want to study sales, that's variable for me. I want to know the association between factory cost and sales. So I want to study the association between two variables. One variable is sales, other variable is factory cost. So whatever I want to study, that can be defined as, in a very plain and simple, informal way, as variable. Are you there?
Yes, sir.
Yes, sir.
Yes, sir.
Remember this, what I'm saying, what I was just about to tell. I'm talking about two variables. So two variable setup, two variable. And I'm going to show variable with the help of X. That's okay. If I have more than one, I might show with the help of X1, X2, X3. I want to show, I may show with the help of Y, Y1, 2, Y3, something like that. I'll use these things, X, Y, Z. Will that be okay with you?
Yes, sir.
Okay, sir.
So I'm saying, let's say talk about two variables, x1 and x2. And I'm saying one of the variable is some definition of time. I repeat myself. I'm talking about two variables at a time. Out of those two, if one variable happens to be time, then I'm talking about time series. I give you examples. Let's say I'm talking about share price. Share price of, let's say, ACC. ACC is a cement company. Share price, and let's say I'm interested. So other variable is time. So what I'm saying, x1 is time, and x2 is sales. Stock price or stock price. Stock price, STK, stock price. And let's say I'm interested in for a 30 days daily. So I've got day one, day two, that way I've got 30 days, I've got price one, S2, and I've got S30. So what you are finding here is two variable setup. Out of two variable, one is one definition of, when I'm saying definition means denomination can be day, week, month, year, decades. So any definition of time can be one of the variable, and you can have any variable on the as other variable in a two variable setup, and that's the example of time series. Am I clear or not? I'm generalizing it. Any two variable setup where one variable is any definition of time can be termed as time series. And here I can have another company, let's say TCS share price. I can add, let's say SDFC limited share price. And then I have got, this, let's say I say, I have to put, A here, ACC, and then I say T1, Let's say here I'm saying HD1, and likewise I go for share price of HDFC on 30th day. So that way I could put all the data. So every time, though I'm putting all of them together, but I can visualize them as pair of two, where one is time, other is the share price, and that's an example of time series data. Are we together? Are you with me?
Yes,
Yes, sir.
Yes, sir.
I'm repeating and I'll reiterate again and again. If you are not clear, just unmute and talk. If you don't unmute, don't ask. I'll take this for granted that you are getting it. You have some hesitation and asking in the class, meet me offline. Message me, email me, I'll help same day. So this is time series. So I'm done with the second thing, time series. I'm moving to, when we handle the financial data, we get cross-sectional, as I was PAT, operating profit, sales, all our financial data, sales price, obviously financial data. So time series, cross-sectional. Now moving to a third category, which is most advanced category or type of data set. We call it panel data. I'm personally have a lot of interest in panel data. My good number of research is on panel data only. I am doing it. I will be doing at least for 3, 4 more years. So panel data is of special interest to me. I'll show you how we can talk about panel data. Very simple way to understand. Still, let's say I'm interested in variable x1, x2. I'll give names also so that you can understand. Let's say I'm interested in sales, and I'm talking about the factory overhead. Factory overhead. I'm saying sales and distribution overhead. Two variables, three variables. That's it. And then, so far there's no problem. I have just talked about three variables. One is sales of a company. I have not written which company. I have just written the name of the variable. Sales, factory overhead. You understand? If I remember my last class, I talked about factory overhead as part of which type of expense? Come on.
So fixed
Yes.
cost.
Fixed overhead. What I'm just
Yeah.
referring here. Fixed overhead is part of which type of,
Operating expense?
operating.
manufacturing operating expense. Manufacturing. Because factory overhead is part of factory means to run the factory or to manufacturing. So it has to be of manufacturing operating expenditure. Good. I'm happy at least some of you remember. So sales and distribution is non-operating expense. Sales and distribution is non-operating. This is operating. Now, if I'm putting data in one of the format, I can change the format. I'll show you both the formats. Let's say I'm talking about 5 companies. And let's say I'm talking about 3 years time period. So look at what I'm doing. 5 companies, something which is coming from the cross-sectional data. If you have understood in cross-sectional data, we talked about 30 companies. You remember 30 companies? So I can take all 30, but just because I have to make you understand the concept, so I'm taking simplified example, oversimplified, five companies. And in cross-sectional, I talk about only 1 year. Time series, I talk about many data points. I'm putting both of them together. And I'm saying, let's talk about 5 companies for 3 years. So I'm putting it that way. Now you can have a look. Let's say I'm talking about C1, company 1. I'll show company with the help of C1, C2, C3, C4, C5. Year 1. So I'm saying year 1, year 2, year 3. So company 1, year 1 data will be entered here. Company 1, I can write here C1, I'm right. I'm not writing so that the board remains clean. C2, so these are C1 obviously. Again, I'm repeating this Y1, Y2. I've got 3 years only. Y3. I've got C4, C3, Y1, Y2, Y3. And I'm just using dash dash dash, which is pretty obvious, and y1, y2, and y3, and all the data points are there as it is. So this is one of the example. This is example of panel data, and presentation is one of the ways where C is out and Y is in. I could have other way around also. I'll show you right away. So are you getting this much or not? Then I'll show you the another format of presenting the panel data. Panel data is a combination of cross-sectional and time series. It has properties of both. So that's why it becomes slightly difficult to handle, but more interesting to handle also. It's not difficult, but interesting also. It reveals more information about the data sets.
So why the term panel?
What's a good name?
Mohit.
Mohit, why do we call you Mohit? Can we justify? Your good name is Mohit. We call you Mohit, same thing.
So for example, cross-sectional, we can understand that at a single
Panel,
point.
actually, it represents like a panel probably. But again, I'm not giving you any logical answer to it. Name, a rows will remain rows, you call it by another name. So panel data can be called tomorrow by another name, doesn't matter. This name is there, panel data.
Got it, sir.
Any other question? Don't ask, I'll assume that you have understood. So please don't do it. If you are clear, great. If you are not clear, ask. Second way I'm showing you, I'm just replacing the time. I'm still talking about X1, X2, X3. As I said, X1 is sales, X2 is factory overhead, X2 is sales and distribution overhead. And I'm now putting Y1 out and C1, C2, C3, C4, C5. I'll show you, I have a lot of data of panel data. I'll show you right away. So, here Y2 and likewise Y3 likewise. I've got 5 firms, no, 3 years. 3 years, so just 3. So C1 to C5 again and C1 to C5 again, that's it. I'll show you real data, probably I may be able to share with you quickly. Just hold for a minute. Look at this data set quickly. Many variables are there here. Look at here. The year and bank, name of bank is there, but when we process, we need to code it. So I've got 34 banks. 34 banks. So if you look at the whole thing, it is getting repeated. For 2019, year is constant, and I have got 34 banks. Data is there, 34. Can you see?
Yes, sir. Yes, sir.
I got a lot of data of banks, 34 bank, their disclosure, their NPA, promoter shareholding. I mean, a lot of variables are there. Yeah, go ahead.
Sir, just asking out of curiosity, nothing else. Sir, UCO Bank has a net NP of 9. Now, I mean 9%, so high.
I think that's a low
Go
figure.
9%, yeah,
Most of
correct.
the
Net
banks.
NPA is 9%, correct. It is like that only. Data is genuine, don't you worry. Data is perfect. Net 9% of their total advances. UK Bank is not in great shape.
Okay.
Don't digress. Stick to the data pattern which I'm showing you. The 2019
So
and
just asked out of
34,
curiosity.
and then we are coming to 2018 and again 34 banks. And then next year 2017, this is 4-year data and 34. And then we have 4-year data. So 2019, 2016, 2016 to 2019 of 34 banks. So as I used here, I said that the N is, N is 5 companies. There I took 34 banks, and instead of 3 years, I took 4 years. That's the example of panel data. So all of you are clear with this? So we are winding up with the discussion of introductory thing. We are moving to second chapter.
Yes, sir.
Yes, sir.
Yes, sir.
So if I wind up the first chapter and give you idea about the topics which I'm going to handle, I will be talking, introduction is over. So I'll be talking about cross-sectional regression. I'll explain what I mean by regression. Cross-sectional, and I'll include time series also, some part of it, and then a little bit more multiple regression analysis. So 2-3 sessions I'll use here. Then I'll go for forecasting. Forecasting of time series data. Like forecasting of your stock price, forecasting of demand, forecasting of sales. So maybe 1 or 2 sessions will be devoted there. So forecasting may be univariate, maybe bivariate. Univariate means when you are forecasting a company share price, then that company data only. But I may use bivariate or multivariate also. So univariate or multivariate, and multivariate may be application of again a model, we call it vector autoregressive model. Very interesting model. You will be able to do everything on your own using software. So nothing which I'm talking cannot be done easily by you. So you will be doing it easily. You will be understanding also everything in great detail. And you have the software. I'll talk about software also. So we'll talk about this. And then we have a typical application of long-term association, which we call co-integration. We'll talk about co-integration, and then we'll talk about something a little more advanced thing, error correction models. So very interesting long-term association of, let's say I'm talking about how developing versus developed economies, stock prices are having long-term association. So that can be studied with the help of co-integration. You can take a call. You would like to understand that whether your company share prices are having long-term association with which countries indices, or within the country you can also find out the long-term association. So very interesting discussion. Again, 1 or 2 sessions will be devoted there. Then we'll have a long discussion on volatility. Volatility has got a lot of applications and risk management especially. We'll have Gauss family of model. You'll understand these terms, don't you worry. It will become part and parcel of you very soon by the time we are finished with the course. Volatility, so a lot of application of volatility. Again, I will have univariate and bivariate. Multivariate we won't be discussing, that's becoming too complicated, but univariate and bivariate application of volatility. So how US stock market, let's say Dow Jones industrial average is impacting BSE Sensex. What is the volatility spillover that can be studied with the help of bivariate? One of the applications. Some real applications I have already done, I'll show you. So regression, cross-sectional time series, forecasting, volatility, and then I can have 1 or 2. If you guys understand well, I'll have simultaneous equation modeling. Otherwise, I'll skip this and I'll move to panel data. So panel data again will take 2-3 sessions. Very interesting to understand how to operate panel data. It reveals maximum information. So as compared to time series or cross-sectional. So that's the rough idea of what we have in classes to come. I'll be meeting you for 24 hours. So excluding today, I'll be meeting you 11 more times. And you'll be having, I think, a few quizzes. I don't remember exactly how many. I noted it. Let me share with you. I'll have 3 quizzes and 2 assignments, including 1 experiential learning assignment. So I don't know whether it's correct. 16 marks. I'll update this again next class. The components of evaluation. It should be 60. I don't know why. Achha, probably you have something. You have something Coursera. Achha, 5 is correct. 3 quizzes, 2 assignment, 1 something extra that will be told to you later on. So 6 components, 5 I have shared, 1 will be shared later on. So any question on that? Any question? So I'm moving to second chapter. Calling it multiple regression analysis. So far, so good. No questions. Shall I start the chapter?
So we need to know the concept of regressions beforehand.
We'll start with that only. We'll start with that only. Anything else? Actually, I want you to have you got one caselet in chapter 2 in the material which I have shared? Have you gone through, any one of you got time to read this paper? I said that skim through this chapter, this paper. Has anyone gone through? So this is one of the applications of regression. You will be able to replicate this probably by the end of 1 or 2 more sessions. Have you got time to read it?
Yes, sir. I have skimmed through.
So which one are you talking about? I didn't understand. Which case? This Acha, yeah. This I've read.
Paras would have shared with you to read one paper. He would have told you categorically. I understand. You guys did miss out. I mean, this was the name. Name was dvmreg.pdf. That was the
It's
name of
shared
the
on
file.
the MS Teams file, sir, as upload.
Everything is shared there. Raw material is there. But this I requested Parag to share, to request all of you to read. If you have gone through, good. If you pay attention to suggestions, you might be better off in understanding. If you haven't read, no problem. I want you to go through one caselet. I didn't know how much time you will take, so that's why I didn't request you to read the caselet, but right now I can at least. You can open this fitness first caselet from your material. Can you open it? I'm giving you 5 minutes time to read it. Can you guys open?
Yes, sir.
Yes?
Yes, sir.
Name of the caselet is fitness first. Very easy, informative, so that we can quickly, and we have data also, Excel. So you can open Excel file as well. Data is like that. So you delete this, no problem. Oh. This much data is with you. Solution is also attached. But right now, pay attention to the problem. Please read the case. This much data, 3 variable. Giving you 5 minutes time.
Sir, I cannot seem to find this file. Can you tell me where it is in our Teams folder?
I'll show you probably. I'll be able to go to files. And in files, you find class material, go there. I'm still in the financial econometrics folder. And there you are having simple and multiple regression. There you have caselets. In caselet, you have fitness first caselet. There you have all the material, including the caselet. Are you there?
Okay, yeah, I got it, sir.
So are you through with the caselet? Can we start?
Yes, sir.
So can somebody give me 2 minutes of brief on caselet? Just a very small brief. What you understood? One person will. Anyone?
Hello.
Yeah, go ahead.
So the caselet talks about the BMI being not a clear indicator of health of a person. So to understand that, they want us to model the correlation between weight, age, and health of using the data provided.
And some questions are also asked that if the students say height or weight is this, I mean height and age is this, what is the good weight which he can have as per the healthy people information? Am I correct?
Yes,
What?
sir. Yes, sir.
All of you are with me. All of you, I guess, have gone through. I could have made some financial caselet. I have one or two more, but I wanted to start with something which is very basic. And we'll move to finance. We'll talk finance only, nothing else. So if you look at this problem, first of all, you need to understand that whatever we are going to learn in this course is the providing solution to the problem and business problems. So no academic discussion. So a problem is there which we started to handle. So right now there is a problem that a few experts would like to know what is the association between weight and other things, because weight is a major concern. Obesity is a problem. Life style disorder is a big serious problem. The biggest medical disorder that impacts our immunity and every other thing. So how we can control weight? That's a different thing. Right now, this model talks about what are the determinants of weight if you have certain height and certain age. And data, if you have gone through the caselet data of 10 healthy people, data is inadequate from the statistical point of view, but I have taken it so that you feel comfortable in handling the data of 10 people only. And you have got only two additional variable in addition to weight, that is height and age. And you have been asked to model that how weight of healthy people is dependent upon height and age of the people, so that that model can be used to suggest people by if you have this much age and this much height and according to the healthy people this much weight or range of weight. I'll tell you how to estimate range also will be good enough for you to have. So don't worry for BMI might be too stringent or primitive, whatever way you call it, but that is something which is practical data gathered. A model is practical gathered from healthy people information, and then this model has been made. Instead of 10, I could have used 1,000 people to generate this model, and that would have become much more meaningful. As I say, drawing the inference about the population. Population means healthy people. So to build a model for healthy people, I have taken a sample of just 10. I could have taken 1,000 or 10,000, and I could have made the model. So that is what the application of inferential statistics. Right now, though it is not a business, but it can be a business problem for health experts or for the gym people. It could be a business problem. So that is what we have right now. So we would like to know a model. I'll come to the modeling language. We want to build a model so that we know how weight is dependent upon. This is the style of writing, function, height, and age. So if I go a little more, a simple way, how weight is getting impacted by height and age. And this model I want to build so that I can suggest people, as I was talking about, of certain height and age, what would be the appropriate weight for them. So that is something which we are trying to, model. When we say modeling in statistics or normal, I say model, there are two types of model which are there. Two broad classification. Again, very basic discussion. I'll start from there and then I'll move to my usual discussion. Have you heard about deterministic model and probabilistic model?
No, sir.
Anyone? Come on. What happened? Deterministic models are relatively very simple models in the sense, uh, simple in the sense that variables are of fixed nature, fixed in the sense 2 plus 2 is 4 all the time. It can't be 5, it can't be 3. But when we talk about business problems, 2 plus 2 may not give you 5 all the time. 2 plus 2 may not give you 4. It may be 5, it may be 3. So when things are not certain, there are always some error. Are you with me? Do you know how to make a movie success? Do you have any ready-made formula? You might have determinants to make a movie success in a film producing industry. Can you tell with certainty, using the best possible model, if you have all these things, your movie is going to be hit? Do you have any such model? Are you listening to me?
No, sir.
So this is the example of where the things are not certain. But in concepts of physics, let's say E is equal to mc square, many such phenomenon, though we may not be able to measure it, but you will find that application of mathematics, physics, they are certain, they are deterministic, they are fixed. If you get everything right, you will get results right. But when it comes to behavioral or business or economics problems, please pay attention. Finance is a subset of accounting and economics. If you go to the history, you won't find finance. You will find only economics and accounting. And then gradually, maybe in the last 50, 60 years, you have found that finance as an area has come up. So, to solve the, when we look at business problems, financial problems, you will find that there are a lot of uncertainties which are involved. And that's why we move from deterministic model to a probabilistic model. One thing is clear, deterministic versus probabilistic model. Yes?
Sir, can you give an example of a deterministic model?
E is equal to mc square is the best. If you correctly measure the mass and E is equal to energy, mc mass and C stands for some physics
The speed
school.
of
C
light.
stands for speed of light. C, yes, speed of light. So you will get the energy. So one can be converted into another. So that is deterministic. So here there are some errors. I'm not saying, but if you can measure the mass appropriately and speed of light appropriately, you will be able to generate the right amount of energy. So there is no error involved. E is equal to mc square is as it is. There is no error involved. But as I gave you example of a movie, how to make a movie successful movie. So having probability of success of movie or probability of successful movie. So you have, let's say you are having variables, different variables. When you run this model, you'll always find some type of error is there. So they can't be a perfect model. There's always some type of probabilistic error will be there, which will always cover those cases where movie is not successful. So that's the example of probabilistic versus deterministic. So deterministic, usually physical sciences have deterministic models, but behavioral sciences, including finance, economics, accounting, you'll find these all come under behavioral sciences, where models, whenever they are made, they are never deterministic, they are always probabilistic.
Okay, got it, sir.
So I was talking about, yeah. So one differentiation is okay, deterministic and probabilistic. One more thing we have discussed about variable. So let's talk about descriptives, because we'll be using descriptives quite often. So what happened, let's say I'm talking about a simple variable weight. So descriptive means sorry, talking about this variable. There are three ways by which this variable can be described. One is measure of certain tendency. I think your stat professor might have discussed. measure of dispersion, and measure of shape. Are you clear with these three terms? Measure of central tendency, we call it averages, arithmetic mean, geometric mean, and all that thing. Dispersion is variability. We use standard deviation to calculate sigma or square of that, which we call variance. And measure of shape, I mean, if I draw the values of the variable here and how many times they are coming, some shape can come. So this is a normal distribution shape. So whether they are symmetrical about the mean value of the variable. So that shape is also, still we are talking about a particular variable, single variable. Shape of distribution of a particular variable is third description about the variable. Are you clear with this? Yes.
So can you explain one more time the last
Your start professor will describe things in detail. It's her job. She will do it, but you are asking, so I'll explain. Like, let's say I've got return. I'm studying the return, let's say on BSE Sensex. Daily return. Daily return. Daily return means day 1, day 2, day 3, and likewise I have got data of, let's say, 5 years. Market works on 250 days per year. So I have got around 1250 data points. Are you clear with this? 5 years, 250 days, normally stock exchange work. So I'll be having the daily closing stock price of BSE Sensex for 5 years, means I have got 1250 data points. Are you with me?
Yes, sir.
So I'm saying prices, prices daily, prices are there. So prices can be converted into returns. When I say return means, let me drop this, start with this, P2 minus P1 by P1. This is P3. So I'll say P3 minus P2 by P2. Like this is P4. So P4 minus P3 by P3. Are you clear? So likewise, I will be able to go till the last point, and I'll say that P1250 minus P1249 divided by P1249. Mohit, are you with me? Yes. Yes.
Yes, sir. Yes, sir.
And R1, R2. Likewise, I have got R, but this will be 1249. What happens when data point gets lost? We use a term degree of freedom. I'll talk about it. So 1 degree gets lost when we convert prices to return. So I had 1250 prices of BSE Sensex for 5 years daily closing price. I converted and made the return. And suppose return may be any number. I mean, daily usually maybe 0.01%, 0.012%. Likewise, you will find data. And suppose I arrange the data in the ascending order, the return data in the ascending order. Are you with me, Jayant?
Yes, sir. Yes, sir.
And on the y-axis, I am plotting the frequency. That so you will find that something like that will come. When data points are good, then you usually get. So if I calculate the average of these returns, R1 to R1249, divided by, if you add all of them and divided by 1249, I'm putting it R bar, which is nothing but the mean value. So this shape, I'm saying that this shape is also a description of a return variable at hand. Right now, presently, I have variable return. So return can be presented. So this shape can be, for argument's sake, it can be, this way also. It is also a possibility, which is not, symmetrical. So that type of discussions, it can be, like this also. It can be like that also. So there are different possibilities of shape. We call it, if you want to know, skewness and kurtosis. Skewness is whether they are symmetrical, kurtosis whether the pickedness is high or too low or usual. So shape matters. These are not my main point of discussion. Just I should use, so I'm just showing you. That's it. Your stat professor will talk about these things in detail. So far, you're understanding what I'm saying or not? That's important. Detail will be given by somebody else. Yes. So I said descriptive, three things, average, variability, and shape. But when we talk about more than one variable, let's say for argument's sake x1 and x2, then we call it measure of relationship. Are you with me? So far we had univariate one variable. I said description of that is done either by average or by variability or by shape. But by the time I have got more than one variable at my hand, I can't individually still I have got all these three available with me. But if I want to know the both the variables together, I want to describe, then that type of measure which are used here is called measure of relationship. There are two broadly measure of relationship are two types. Like here I can talk about average. So average can be mean, average can be mode, average can be median. So three measures are there to describe average. All three are types of averages. Similarly, this is measure of central tendency. So I'm talking about measure of, don't worry for terms, you'll become used to of it. Right now, you might be listening to them first time. Don't you worry. Measure of relationship. There are two types. One is correlation. Somebody was asking with me. Another is regression. So when we want to know measure of relationship means we want to describe two variables together. It can be done in two ways. Like I gave you example of three types of averages. So measure relationships are also relationships can be described between two, and in some cases more than two also. Correlation more than two becomes problematic. So I'm keeping it my discussion right now to regression can be between many items, no problem. But let me at least start the idea. So that's what I'm saying. So correlation and regression. So far, so good.
Yes,
Yes,
sir.
sir.
Now we are starting my course. With this, I'm starting my course. So far, whatever I talked, that was just general talk. I'm starting my course. So my course will start with correlation regression, predominantly regression. Correlation should be there, so it is there. Let me define correlation. All of you, please pay attention to me. Correlation means trying to find out the degree of association. Pay attention to my word which I'm using, degree of association. It means two friends are there. One friend bunks the class. What is the probability that other person will also bunk the class? So when we just look at the degree of association, we do not know the exact relationship. Then we are talking about degree of association. Means we are just interested in knowing the tendency. If one will go, what is the tendency that other will also go? Tendency. Only what is the degree of association? On the other hand, when we want mathematical description, something like that. If x1 will be equal to something, 2 plus 3 x2. So if x1 is student 1, and if he bunks the class, suppose x1 is bunking of the student 1, so what are the chances that x2 will also bunk? So if x2 bunks, what are the chances of bunking of the x1? So that way, that type of exact association or exact relationships, when they are established, we are talking about regression. So correlation is something where we just assess the degree. Degree is assessed on the scale of -1 to +1. Means if x1 goes up, what are the chances that x2 will also go up? So let's say association degree is 0.60. 0.60 is between -1 and +1. So chances if x1 goes up, let's say price of x1 goes up, so price of x2 will also be going up. But by how much? That exact relationship we don't know. We only know the degree of association. Suppose for argument's sake, between share price of X3 and X4, the correlation R, which is used to show the correlation coefficient, let's say it is coming out to be 0.20 minus. It means if X3 share price will go up just because association is minus. So as per the result of correlation, I'll say that X4 has got chances to fall and the chances are 20%. I mean, if it goes 100%, then X4, X3 goes up, then X4 may fall. It has got 20% chances because it has the negative association with the X3. So this description where we just get to know the degree of association, we are talking about correlation. But when we find out the exact mathematical description.
Sir, I couldn't understand. Can you please repeat once again?
Just 2 plus 3 x3 x4, then I'm talking about a regression. Yeah, ask me a specific question.
So can you please repeat this part once again? I couldn't.
What I'm saying, let's say two company BSE Sensex. BSE Sensex is what?
It's an indices. I mean, it's an index.
It's an index, Indian stock market leading indices. And one of the leading indices is BSE Sensex, which is BSE 30 leading stocks. They are used and indexes there. Dow Jones Industrial Average is the New York Stock Exchange leading index, again of 30 stocks. BSE Sensex and Dow Jones Industrial Average both are comparable, 30 stocks. Suppose I have got prices of last 1 year, daily closing price, roughly 250 days. They also work, we also work because weekends they also keep it off, we also keep it off. So roughly 250, same days we have got data. And I just want to understand degree of association. So I'll run regression. I'll have, let's say for argument's sake, it is coming out to be 0.72. Degree of association coming out to be 0.72. It means if Indian stock market will be impacted by US stock market, let's say, or other way around also, because degree of association is not which is cause and which is effect. Association is having a degree of 0.72. First, it is positive and association is 0.72. Means if US stock market goes up, chances that Indian stock market will also go up is 72%. Or if Indian stock market goes up, chances that US stock market will go up if degree of association is 0.72. So if Indian market goes up, then chances that US stock market will also go up is 0.72%. Percent may not make sense, but degree of association in terms of correlation will say that 0.72 is the degree of association and chances that it will go up. Make sense?
Yes, sir.
Suppose US stock market goes up by, let's say, in a week, 1%. And we want to know how many percent Indian stock market will also move if US stock market moves up by 1%. That cannot be done with the help of association, descriptive association or correlation. For that, you have to have a mathematical description. So exact association when we explore, like as I said, US Indian stock market is equal to something plus US stock market. That is what is known as regression. To finding out the exact association is regression. And when you only try to find out the degree of association, not the exact mathematical description, we are talking about correlation. So degree is correlation, exact association is regression. Our job is regression, not correlation. The whole semester will talk only about the exact association between different variables. Are you with me, all of you?
Yes, sir.
Yes, sir.
So this is what we are going to discuss in the. So I'll show you. I have a caselet open. I'll show you first of all. Yeah, come again.
So I had a doubt. So sir, correlation would give us the probability of another like if there are two variables, the probability of the relation that have positive or negative relation that the
First
other
of
thing
all,
will change.
positive or negative. Very good, Mohit. You are then going the right direction. Degree, nature also, whether it is positive or negative. That is the first thing. Second, what is the degree of going plus or going minus?
So that I got. What I want to know is will regression include the degree, or would it require correlation to understand the degree?
Practically, what happened when we talk about simple regression, where we have only two variables, one dependent, other independent. One is causing the effect on other. Then correlation and regression might give you same answer. But when we have more than one independent variables, then that statement may not hold true. You understand? So they have similarity, but regression is a higher degree instrument to understand the association. So it's a higher degree of measure of association, measure of relationship, if I call it that way.
Okay. So another doubt I had.
Uh-huh.
So regression would give us an expected value of the another variable.
That depends whether you are interested in knowing the expected, you would like to use regression for prediction. That's your choice. You can obviously use for prediction, but you
So
just want
if
to
we
know
are doing
association.
that, so if we are doing that, would there be another probability? Like, what will be the probability that this expectation will come true?
No. That way we have different models to handle. Right now, we'll only get to know what is the degree of whether we are running regression. When we run regression, we'll understand the mathematical description. And mathematical description, for argument's sake, the US market is moving up by 1%. By how many percentage Indian market will move? So you will get just an answer. Let's say 1%. Let's say for argument's sake, it is giving you answer of by 0.73%. So 0.73% is the result is coming with the help of regression analysis. And there will be some error also that will also be discussed. What are the chances of this answer is correct or not correct?
Okay, sir. Okay. So the error will be the confidence percentage.
Confidence interval, we can say, level of significance, which we call it.
Okay.
Don't hurry, no rush, go slow. So I hope the point is clear. The forum is still open. I have 10 minutes, more than 10 minutes time. Tell me, regression correlation is clear to everyone. I'm saying now we have started the course, so I can't afford you not to understand even a single thing. Unmute and talk. Right. I have in the the shared material. I have shared with you. Let me this yeah, filled pro forma for fitness first. So this pro forma, as you're finding it, I think I have given you pro forma here. No, okay, I'll give you blank pro formas also. You have this. You have template regression analysis. So you have this. These three Word files are there, which are template to report the regression, because we'll be doing regression as I have shown you with the help of this paper, something like that. So before that, you are having this. So all these reports, the way they are reported, so I have intentionally made some pro forma, so that becomes very easy for you to replicate the what we do or report anything if you come across. I'll show you the filled ones so that you feel confident. This is the regression output. Before that, we have descriptive and we have 5-pointer discussion also. So that I'll take up in next class. I'll show you. Look at here. So, this is constant height, and yeah, I'll discuss these things in detail. A lot of very insightful discussions we'll do. So it can be made, in no time it can be made. Because we have software, so immediately if we have data ready, we can straight away process by click of mouse. Again, this is descriptive. We are having the mean, standard deviation is sigma, mean is nothing, arithmetic mean, and then correlation coefficients. I'll tell you how to calculate and how to report. Everything I'll discuss with you. VIF you'll understand by at the end of second or next class. And these are two things. I repeat, this is regression result, this is descriptive. So this is table 1, this is table 2, and third table, it's not table practically, it is how to discuss the results of regression, 5-pointer. Look at what is this coefficient analysis. Just right now you listen to these terms. You will be able to do it on your own without any problem. Coefficient analysis, model interpretation, diagnostic testing, parameter stability, and then how to calculate range. When I was saying that I'll be able to give you the range. So this is the fifth point which I'm talking. So, practically, we'll be having this first problem which I have given you as caselet. We'll be talking about it, fitness first, and we'll be generating the information and putting it in the templates which I have made. 3 templates. One template is for descriptive, other template is for reporting the regression results, and third template is for discussion. So that is what we'll be doing. Any question?
No, sir.
So which
You
one?
can open
Tire
your start. Yeah, tell me.
Yeah, the second caselet, that means the tire track one, no?
Right now we are handling the first caselet. We'll handle all, no problem. Next class we'll handle all. Right? Tire track, I think mutual fund caselet is also a little more finance oriented. Tire track, CEO salary, mutual funds, all 4 cases we do. Open your startup and you have your Excel file ready with you. I'll show you how to enter data in Excel. This is the data which you have. Have you opened? Have you opened your startup?
Yes, sir. So my software is asking for a license.
I don't know. I think you guys have got some crack and all. You check with Parag. Parag, are you there?
Yes, sir. I'll have a look at
Yeah.
it.
What
This.
what is it asking for?
Yeah, it's asking for a license.
Okay, I don't know. Mine's still running instantly.
Okay, Mohit, you can discuss this with
I-
Parag later on off
Okay,
the line.
okay.
And you have still a problem. I have equipped him with everything. He will help you in all the way. He will connect with some more people who will help you. And at
Okay,
the end, if nothing works, come back to me. I'll help you. But I have given him enough resources, enough people, contacts. In no time, your problem will be sorted out. So if you have this with you, all of you, I believe that rest of you are having this ready with you. This.
Yes, sir.
Yes, sir.
yes, sir.
So go to the file. File as you go, you have got import option and then Excel spreadsheet. Can you go up to this?
Yes, sir.
Click it. It is something import Excel, that type of window is there. Are we together, all of you?
Yes, sir.
Yes, sir.
Go to browse and wherever you have got this Excel, Excel has to be in this format. I repeat, only first cell should have the field names and rest should be like that only. If you have, then you won't have any problem in getting the access.
So, sir, we should download the Fitness First Excel and export it to startup.
That is the best way. That is the best way to work on a startup. So, like yeah. Yeah, fitness first. So once you enter browsed, I have selected, then you go for import first row as a variable names. This also need to be selected. I repeat, I have gone for browse, I have selected my file, opened it, and then I have ticked this import first row as variable names. So,
Sir, can you please, sir, I was downloading the file. Can you please repeat this part once again?
so what I'm saying, go to file, after opening Stata, go to import, Excel spreadsheet, browse, wherever your location is, select, open. And once you have done this, don't forget to click that import first row as variable names. Are we good to go?
Yes, sir.
Yes, sir.
Those who are not following, that will become difficult for you. Every passing class, every next class will become much more difficult. And if you follow me, it will be cakewalk. Though we are talking about panel data, which is supposedly very difficult, I'll make it very easy. The only condition is You follow me, and wherever you are stuck, ask. If you are asking and following, I don't think so. Even a single line of this course will not be clear. That's not just not possible. So go to OK, and here we are there. On the right side, you will find that all the variables, 3 variables. Some are there, just ignore. I mean, we are more interested in these 3 things. So they are there. Weight, height, and age. I can go for, you want to know, I'll write summary. I want summary, SUM. I'm going to the command section. I'm writing sum. Are you with me?
Yes, sir.
I can write WT, the name, all are case sensitive. So you have to be very clear. Weight, HT, height, and age. I could have also, writing sum, one space. I would have gone to weight, clicked. Now, as you're finding, I'm clicking, it is coming. So that is also ways when you have many variables, sometimes I do that way also. I've got some weight, height, age. I'm just going to put enter. And I've got the elementary statistics. How many observations of every variable? 10. Their mean, their
This is
standard
wonderful.
deviation, mean, and maximum. So where the softwares, they have no end, whatever way you want to use it. There are many other software. We have SPSS, we have SAS. SAS we have discontinued this year because of no utility. So for econometrics, statistical analysis, especially in financial and economic data, we have 2 licensed version, the eViews and Startup, both I'm using. I'll show you how to make use of up to this in eViews also. eViews, we have this. Can you open eViews?
There's 7 software and they're on your system. There's 7 software and they're on your system.
Can you open Startup? eViews.
Yes, sir.
So if we have the eViews, this is the eViews, this much will come. Whatever comes, you cancel it. Go to File, New Work File. Are you with me, all of you? File, New Work File.
Sir, just a second, it's actually loading. Just a second.
Okay. I may stretch 2 minutes extra. There's already 1:28. I may take 3 more minutes. It will be 100% done by 1:35. I've clicked the,
So what do we have to do?
just go to File, New Work File. You open, this will be, first thing which will come. There you are finding data, regular frequency. Click here and make it unstructured, undated. I repeat, work file structure type, you make it unstructured, undated. Number of observations, you have 10, excluding the field name. So you have 10 observations, put 10, that's it. Are you with me, all of you?
Yes, sir.
Go to OK. We have got this. Now to start with, go to quick, empty group. Quick, empty group, click. This will be open. Just click here.
Sorry, a quick then. Can you show it once again?
I'll show you. Quick, empty group.
Okay.
Click.
Okay.
Then you click at the first cell and take the cursor 1 step ahead. It will be going there. So you are finding one row which is there for names. So up to here, everything is okay. Go to the Excel where you have got the data and just, you can ignore this. You can have only 3 variables which is of your interest, including the field name. Go for Control C, copy it from Excel, go back to the this, and you click where you have the blank row which is meant for name of the variable. Copy, paste. Are you with me?
Sir, I actually lost it. I didn't understand only. So I created that, like you said, 10 observation and this thing, but then I lost it.
Okay. I'll repeat it one more time. That's it. Then we'll take it next time.
Just repeat from the start, so in case I did something wrong in the start.
Go to quick, empty group. This is clear.
Yeah.
Click it, take it at 1 step ahead. Go to Excel, Control C, whatever you want. All variable name as well as data. Come back, put the cursor here and control V.
So when I take it one step up, it says alpha 01 and you can't edit that.
Meet me offline right now. I don't know what you're saying. Meet me offline. You try again what I'm saying. Otherwise, you meet me offline. Just message me. I'll help you. Right?
So basically, we are not able to create the empty row in which names are coming.
You click it and take it one step ahead. Na? Just put the cursor ahead. It will go.
Okay, so I'll try again.
Just click at the first cell. Like, I've got this. If I no, it's because I've entered, so it will obviously take it. It will work. Don't you worry. It will work. Try again. I'll
Yes,
show you
it
again.
worked. It worked.
It will work. You have to become a little more comfortable. That's it. So you have work file. This you can save. You are finding that these three variables are there. Two will always be there in addition. C and reset. Don't you worry. Let them be like that only. Age, HT, and weight. Three variable we wanted. We have got. You save it and keep it safe. Wherever you want. You give it a name. Let's say regression analysis and put your name. Let's say I'm saying my name. You can have your name and it's saved. So it will ask for one more command and you'll find that you are having, this is saved on my desktop. And here, and if I just want to know, I'll click all three.
Sir, I deleted the new
No problem, do it
class.
again, do it again, do it again. No
Okay.
problem. Suppose I want to see what has entered, select all three variables, right click at one of them, open as group. And that's there for you.
Okay.
So we are closing today this much. You learn how to enter data in both the systems as eViews and Stata. We'll start from here. We'll start with the fitness first caselet. We'll start learning how to process it. Fill the template. 3 templates will be filled. So we'll start with questions of first session. So whatever question, 2-3 options, you right now message me, I'll get back to you. You ask with your friends, try to work it out, and still you have problem. You don't want to talk to me right now or offline, online, then you can wait for the next class to come. Again, I'll give you option to ask questions. And then only I'll start with the discussions of the next class. So I'm closing it.
Sir, I had a doubt. Sir, in Strata, when we click on browse and we put the file, sir, after it appears, we should click on import first row as variable names.
Correct.
And import all data as strings. Both we have to select.
No, string is not mentioned here because data is not string. Data is all numbers. If you have a string, then you correct it first in Excel.
Okay, so
you check your Excel. Excel is having problem. It should be number only, except the first row, which is the name of the variables.
Sir. No, sir, I'm asking, sir, I browsed the file. I uploaded fitness first in this in the Excel file column. And then after that, I have to check mark import first row as variable names and then okay,
that's
right?
It, that's it. Okay. Yeah, it will work.
Okay.
It will work like this. It will work like this. I've given you some HT we have taught. It is coming. I just checked it also. It's working.
And the variable case will be preserved, sir, right? Not lower
Everything
up.
will be by default there. You need not do it. You want to learn it, learn on your own offline. No problem.
Okay,
But
okay.
this is working because I've checked. Everything is in order. So Excel file which I have given you is appropriately correct. Nature of the variable is also correct.
Okay, sir. So on just I have to tick mark import first row as variable names and okay.
Yes, yes.
Thank you, sir.
Sir, can you hear me? Sir, so the not Stata, sorry, eViews version that we have does not allow us to save file.
No problem, no issue. Keep in the Excel.
Yeah.
And then when we use, understood, no problem.
Basically,
it is possible.
It is
whatever
possible. We do in one lecture itself because there's no save.
No problem. You keep everything safe in the Excel.
All right.
When we have to process it, we'll take results will come, note it, and move on. And you have a Stata will remain, which will work. If you have got the right file, it will work. So Stata can be more handy in that. Okay, we are closing. We are running out of time now. Okay, we'll meet again next week. Not clear? Get back to me offline. Message me, email me. I'll help you.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.